right, back for the middle of 122. One thing I want to talk about is the call by value. And it brings up the difference once again between formal parameters and actual parameters. Actual parameters is like when you put a number in there. Formal parameters are like when it says int slices, when it's using a variable name to help with the coding and where to put each variable. Actual parameters are when you put numbers in there. So what happens in the code is, when you use a call by variable, it takes the actual number you type in and stores it or initializes the formal parameters with it. So when you look at this one, with this int t, if you type a number in there or a double, what it does is it turns it into an integer like we changed earlier and stores it as tiers. So it automatically initializes this variable tiers as this integer t. So whatever number I type in there, it's going to take the formal thing called t and turn it into an actual one called a number. So let's see what happens with that one. Okay, so before double t is 3.0, so it's worth 3.0 first. Then at the end, it's worth 3.0. And this says, I thought it was kind of interesting. It says, what if we changed it inside of the cake constructor? So we're going to copy this. I want to make sure we use the double one and see what happens to t. So inside of cake, we want to get inside a double. How about right here? We'll paste that. So basically, you're going to throw a couple of system out prints. These right here. So we're going to see what t is worth once you're inside, and then we're going to change it to 0, and then see if that affects the outside. So let's run it, see what happens. Oh, look. It's before it was 3.0. Inside, it started as 3.0. And then it changed to 0.0. And at the end, it's 3.0 again. So it's kind of like a self-contained unit. This will not, even though I reset it to 0, it doesn't change the 3.0 on the outside. It doesn't, it's kind of like self-contained. You can mess with t inside here, but it won't change on the outside. And you might have thought it would have turned to 3 because it's cast as an integer. But that wasn't stored as t, that's tiers. So if I go in here and say, make a new print line, here is what tiers is stored as. Okay, and then we're going to write okay. Spell it right, I think. The semicolon. Let's see what that does. Boom. Yeah, see, there's the 3 you were expecting, but it didn't store it as t, it stored it as tiers. I don't think it would know what it was on the outside. Let's see, just for funsies. Oops, did I change something over here? Pump fingers. Alright, let's go. Let's see what this is. See, I bet it'll throw an error because it has no idea what tiers are outside of there. Yeah, it's like, what the heck is tiers? Tiers is self-contained in here. It's like its own little island. It doesn't let stuff out. So that's why I was confused. I had a feeling that would be the case. Sometimes you don't know till you try. Okay, so that's some interesting stuff for call by value. Watch this video to actually get a good understanding of how it works. null value is an important thing to know in here, because a lot of times one of the biggest errors you'll get is a null pointer exception. So let's check out a little bit about null value. So a common thing we want to do is not just make a new cake, but store it somewhere so we can use it. Make a cake object. One thing you'll see you can't do is you can't store a cake object as a double. Cake is not a decimal number. Just isn't. So don't try to store it as a double. That's why there's an error here. What we need to do whenever you store an object and whenever you create and store an object, you need to, you know how you need to like title something or declare it an integer if it's going to be an int, or a double if it's going to be a double, or a boolean if it's going to be a boolean when you made variables? Well, if we want to make a variable that stores this cake object, we need to tell it what type this variable is. And it's not an int, it's not a double, it's a cake item. How do you know it's a cake item? Well, it's produced by a constructor in the class cake. Okay, there's the constructor, this is the class. So when you look down here, you're like, I will be making a cake variable called myCake, and it will be the object. This is the new keyword that makes the object. It calls the constructor a new cake object, and it's going to be stored there. It's not a double, it's not an int. This myCake is called an object reference. Basically, that shows, it points it to the place in the memory that stores that object. Okay, so yeah. So if we went up here and we fixed this to say not a double but a cake object, we'd be like, wee, hey, it worked. You don't need these print statements here. Get rid of that. We'll keep the other one because that makes it run in double. Here we go. Drew a cake, stored it. Alright. Okay, now we're going to make some more cakes. You know, why not? We're going to make one with each one of the constructors. So if I copy paste this, okay, we're going to make myCake 2, myCake 3. I'm going to call it myCake 1. Okay, so first one's made with this 3.0 t variable. I want to use one that has nothing in it for this constructor, and I want to use one that has a integer in it for the other constructor. Maybe a 3 because we're cake 3. Okay, there's all three of them. There's a 3 tier. Maybe we'll call this 2 just because it's 2 tier. Not that it makes a difference. 3 tier, 1 tier, 2 tier. So something weird about it is, you know how I said it stored your cake? If we do this, you want to see what it stored it as or where it stored it. If you go up here and you system out print myCake, ooh, I should make that myCake 1. If I want to see where it stored this original cake with the 3.0, not where it stored it, what it stored it as, you hit run, and look at this. myCake is cake item at this place. Okay, so this is the location in memory where it stored the object that I named myCake 1. Okay, and if I did a similar thing with each one of these, like myCake 2 and myCake 3, you would expect them to be all different numbers. Why? Because they're different objects stored in different places in your memory. Yeah. Did this first one change? Let's see. This was 15. Let's see if I run it again. Nope, same place. So it's not changing each time. It's the same cake. So that's kind of showing you where it stores it. And here's an interesting thing. So we make a new cake objects, but instead of like here where I said myCake 1, I'm calling the constructor new cake t. I'm just making a cake variable called empty cake, but I'm not initializing it. I'm not creating something out of my constructors. And then when I go to print this out, I don't know if you should predict what's going to happen. What do you think it's going to do? Well, it doesn't work, that's for sure. But what it says is variable might not have been initialized, and it wasn't. We didn't make a cake object. We just said there's a variable of type cake, but it has nowhere to reference. This thing is supposed to be calling sort of like these guys. They call on, when we printed this out, it would tell it where that object was located. There's nowhere this object is located. It's not connected with an object yet. So if you're a programmer and you know you want to use empty cake later, you just don't have it in your code yet, you can avoid this error by setting it equal to null. Null is like the empty space. Let's see what happens here. Boom. Look at that. It worked this time. It didn't freak out. It just says it's null, which means it has nowhere to point to. Okay, like these have addresses, and there's something stored in each one under my cake. 1 and 2 and 3. I should probably do that just for professionalism. But if you don't want to store an object in cake yet, you can store null there, which is pretty much, the word for nothingness or empty. So it is okay with that. You don't have to, if you don't feel like making an object right now because you're going to later in your code, just put a null placeholder there. It'll work. All right, so the rest of this you should be able to handle. Keep on cruising. Make sure you are writing down in your notebook the keyword null, the special value to indicate that a reference variable is not associated with any object. Like we didn't actually make a new object to store an empty cake, so basically means nothing's there. All right. Now, don't do this Visual Studio Code because we're on Chromebooks. Unless you're not, then you could do it. And then make sure you answer the conclusion questions, which says write the code that would instantiate, let's see if you remember what that word is, 2 objects with object references using the following class. So we have int num pages, public book, system out print, create a book, public book int p, create a book with p pages. Identify all formal and actual parameters. All right, so try that out. Talk to you later, folks.